Hi, welcome to Fitness Facts. In this video, I'm going to cover muscle strength and fiber types. After watching this video, hopefully you'll better understand the reason behind different training routines and performance outcomes. Let's get started. Muscle strength or force production begins with motor units, which are the neurons in all the muscle fibers they stimulate. These neurons transmit impulses at different rates. Slow motor units stimulate slower type 1 muscle fibers. Fast fatigue resistant motor units stimulate type 2A fibers, while fast fatigable motor units stimulate type 2X fibers. The terms fast and slow are relative, as the impulses in slow neurons travel at about 110 miles an hour. Interestingly, if you take a slow motor neuron and attach it to fast twitch muscle fibers and stimulate those fibers repeatedly, eventually they'll turn into slow twitch fibers. Something that's not really practical, but kind of cool. Motor unit activation allows for a wide range of forces that a muscle can produce, from activating just slow motor units, or activating slow motor units plus fast fatigue resistant motor units, or activating all three. This hierarchy produces forces from light to moderate to maximal respectively. Also, motor units can fire from low frequencies, which result in low force production, all the way up to a high frequency, which results in maximal force production. Muscles contain hundreds of motor units, which comprise of all three types. So the number and type of motor units that are recruited and the frequency at which they fire determines the amount of muscle strength or force that's produced. I'll apply this to strength training in a few minutes. Muscles contain all three fiber types, type 1 which are slow twitch, and type 2A and 2X which are fast twitch. Type 1 fibers produce less force because they have fewer thick and thin filaments, a slower version of myosin ATPase, and a slower contraction speed due to slower moving myosin heads. They also have a less developed sarcoplasmic reticulum and slower calcium pumps. But it takes a lot to fatigue a type 1 fiber because they have a lot of aerobic machinery like mitochondria, myoglobin, and surrounding capillaries. Type 2X fibers generate the most force for the opposite reasons. More thick and thin filaments, faster ATPase activity, faster moving myosin heads, greater sarcoplasmic reticulum development, and faster calcium pumps. But they fatigue very quickly because they rely mostly on anaerobic rather than aerobic ATP production. Type 2A fibers generate force similar to 2X, but they're a little more energy efficient, which gives them more endurance. The more type 2 fibers a muscle has, the greater its strength potential, but also the faster its fatigue rate. Now, let's zoom out from the inner workings of the muscle and look at other factors that influence muscle strength. As I mentioned at the beginning, muscle size is one of those factors. And this is because large muscles have more thick and thin filaments. This means that there are more myosin heads attached to more actin, and that's where muscle force is generated. But the muscle hypertrophy that comes from strength training doesn't just mean that there's more thick and thin filaments or more myosin and actin, but there's more sarcoplasm or fluid inside the muscle, which doesn't contribute to muscle strength. I cover this concept more in my video on training for muscle strength versus size. Since muscle force comes from the cross-bridge attachment between myosin heads and actin, a slower contracting muscle will allow for more cross-bridge attachment between myosin and actin, therefore generating more force than a faster contracting muscle with fewer cross-bridges. Obviously, lifting something heavy requires a slow contraction, but now you know why that actually helps. The length of the muscle during contraction also influences strength production. For example, at longer lengths, the thin filaments are pulled away from the thick filaments, reducing the number of possible cross-bridges. A shortening muscle, on the other hand, can eventually lead to thin filaments overlapping, also reducing cross-bridge formation. This is in part why you have some sticking or weaker points during some lifts, like a bicep curl. Even the pattern or the arrangement of muscle fibers impacts the strength of a muscle. For example, a pennate muscle has fibers that align obliquely with a tendon, creating a feather-like pattern. Muscles with a greater pennation pack more filaments into the same area, so they generate more force but contract slower than a non-pennate muscle. With training, the angle of pennation changes, favoring greater strength. Now for some application. One key to producing maximal strength is the number of motor units that are activated. There's an order to this activation, with slow motor units being the easiest to activate and therefore the first recruited. If the contraction requires more force, then fast fatigue resistance motor units are activated along with the slow motor units. Maximal strength comes when fast fatigable motor units are included in the recruitment process, but they're very stubborn and difficult to recruit, which is why, even though they may not know it, some athletes yell to try to maximize their strength. With strength training, more fast fatigable motor units are recruited during maximal contraction, leading to a higher level of strength. This is something that happens before the muscle hypertrophies, meaning the muscle becomes stronger before it becomes bigger. While type 1 fibers are very fatigue resistant, they do tend to tire over long periods of endurance exercise like running, swimming, and cycling. As they fatigue, their lost force can be replaced by activating faster motor units. First with fast fatigue resistance motor units in their 2A fibers, and then if necessary, fast fatiguable motor units in their 2X fibers. But since these faster motor units are more difficult to recruit than slow motor units, the exercise will feel harder, even though the amount of force, for example to maintain a running speed, will be the same. With endurance training, 2X and 2A fibers behave more like type 1 fibers, giving your muscles more endurance and making the exercise feel easier. Most women don't have the same absolute strength as men, which is mostly due to men having more muscle mass. When compared on equal terms as strength per amount of muscle or muscle size, skeletal muscle produces 3 to 4 grams of muscle force per centimeter squared, regardless of gender. With strength training, women and men both get stronger initially by recruiting more motor units, which increases muscle strength but not size. As the training continues, muscle size will increase in both women and men, but more so in men because of higher testosterone levels. I hope this video gives you a better understanding of the factors that contribute to muscle strength, and how those factors can impact training routine options and performance outcomes. Post your comments and questions in the comment section below, and I really look forward to responding to those. As always, my answers come from peer-reviewed research linked in that comment section.